Good afternoon. Today I would like to talk about the physics of the working of a moving bicycle as well as a bicycle that would come to a halt when one applies brakes. Firstly, let me get into the topic right away. Initially, while one pedals or presses on the pedal of a bicycle, they're exerting a certain amount of force, and that force is getting the effect of that force is getting translated into the motion of the back wheel, which moves, let us say, in the clockwise direction. So you're pedaling in the clockwise direction, the back wheel moves in the clockwise direction. Now in between the pedal and the back wheel there is a chain. I would not like to talk about the effect of this chain, what really happened. I'll talk about the effect of this chain, how the power gets transferred from the force of your pedaling to the back wheel through the chain. I'll talk about it probably in another video, but in this video I would like to confine to what happens to the back wheel and what are the forces on the back wheel when one pedals on the bicycle. Once you put some force on the pedal, the back wheel moves in the clockwise direction, and because the back wheel is turning, it will have some velocity, it will have some acceleration. Both of these quantities are that which are related to turning, so they are angular velocity and angular acceleration. So in effect, the back wheel will have an angular motion in the clockwise direction. And this entire angular motion is caused because of a force, and that force is coming from uh, when you press on the pedal. That force comes from the person who is pressing on the pedal. Whenever there is a force and whenever there is a rotating object with a certain radius, and that force is causing the object to rotate, we say that the object is associated with a quantity called torque, and torque is something which is directly related to the turning effect created on the back wheel due to the force applied on the back wheel through the chain. So in this case, the torque is in the clockwise direction, and it depends on the force applied on that wheel through the chain, and also it depends on the radius of the wheel. The chain in effect is the main thing that is applying the force on the wheel. Secondly, uh, let me tell you to visualize what happens at the point when the tire is in contact with the floor. So when the tire is in motion, when the tire is moving in the clockwise direction, the tire is in motion. At the same time, the tire is in touch with the ground. So if if you visualize the point where the tire is in touch with the ground, you will see that that point moves towards the left. It moves horizontally towards the left, and whenever there is a relative motion between two surfaces, in this case between the tire and the floor, in this case the tire is moving, there will be a force that opposes the relative motion of the tire with respect to the floor. And this happens because there are some microscopic irregularities between the floor and the tire, and these microscopic irregularities can be thought of as certain hills and valleys associated with the floor and the tire. So when these hills and valleys of the floor and the tire come into touch with each other, in effect they lock with each other. This causes an opposition to the actual direction of motion of the point which is in touch with the floor, the point of the tire which is in touch with the floor, and this opposing force is called friction. Right now, while the bicycle is moving in the clockwise direction, the bicycle has a tendency, when the back wheel of the bicycle moves in the clockwise direction, the point on the back wheel which is in touch with the floor will have a tendency to have a linear motion towards the right. And this motion can be thought of a tendency of a relative motion of that point with respect to the floor, and it will be towards the right and it will be horizontal. And because of this relative motion or the sliding effect of the point which is in touch with the floor, the point on the tire, there is a force. I told you, the friction force caused due to the interlocking of the hills and valleys of the tire as well as the floor, and that friction will oppose the tendency for the relative motion of the point on the floor with respect to the point on the tire with respect to the floor, and therefore the direction of the friction will be horizontal, but it will be towards the right. The tendency of the wheel to move linearly is happening towards the right, is happening towards the left, and the frictional force is in a direction opposing that motion, and it will be towards the right. Now this frictional force has many effects. The first effect is like the force that a person causes by pedaling on the wheel, by pedaling on the bicycle. Like that force, there will be like that force produces a certain torque on the back wheel. There will be a certain torque produced by this friction, which is in direction to the left of the point which is in touch with the floor. And this friction will also produce a turning effect on the back wheel, and this turning effect will be in the anti-clockwise direction. Now you have that the back wheel is moving in the clockwise direction, but the friction is causing a torque or a turning effect in the anti-clockwise direction. Eventually the clockwise torque is higher than the anti-clockwise torque produced by the friction on the back wheel, which is towards the left, which is acting horizontally towards the left, opposing the sliding tendency of the back wheel to slide towards the right. And the second effect that this friction on the back wheel has is that, and this is a more important effect because it causes the bicycle to move in the linear direction towards the right. And this effect has got to do with the fact that this friction has the power to cause a tendency for the front wheel, for the center of the front wheel to move towards the right linearly, horizontally. It only gives that center of the front wheel a tendency for it to move towards the right. And when that happens, when the point tries to move towards the right, once again, if you were to go and visualize the point of the tire which is in touch with the floor on the front wheel this time, so far we have seen it happen on the back wheel. Now I would like you to visualize what happens on the front wheel at the point of contact of the tire with the floor. At this point, that point will have a tendency to move towards the right, horizontally, linearly, because the friction on the back wheel is horizontal and linear at the point of contact of the tire and the floor. And because the point of contact of the tire and the floor or the front wheel has a tendency to move forward, has a tendency to slide, once again there will be an opposition to this tendency. Because there is a tendency of relative motion of the front wheel with respect to the floor, there will be an opposition to this tendency, because the hills and the valleys, the irregularities of the wheel and the floor would interlock with each other, and this has an effect to cause an opposition for the tendency for the front wheel, or the point of contact of the front wheel with the floor to move towards the to move towards the right. And this opposition is once again the friction, and this friction tries to cause an opposition of the sliding motion of that point of contact to the tire and the floor. Now this friction has a different effect compared to the friction on the back wheel. Let me focus a little about the friction on the front wheel. The friction on the back wheel also tried to produce a net turning effect on the back wheel, and it has a turning effect. It has a torque on the back wheel, but it is ultimately the clockwise torque produced due to the press on the pedal of the bicycle that dominates the torque produced by the friction on the back wheel, and hence the back wheel moves in the clockwise direction. But if you were to focus on the front wheel, the friction on the front wheel is horizontally towards the left, and the friction on the front wheel now causes a turning effect on the front wheel, because there is a radius for the front wheel, and there on also the force itself involved in the process is the friction, and this causes the front wheel to turn, and it turns in the clockwise direction, and ultimately the bicycle is set into motion once the front wheel moves in the clockwise direction. What I would like you to observe when the bicycle moves is that the friction on the back wheel has to be greater than the friction on the front wheel. The friction on the back wheel is horizontally acting against the relative motion of the back wheel, and it is in a direction to the horizontally to the right. It is acting horizontally to the right. The friction on the front wheel is acting horizontally to the left. It is the friction on the back wheel that dominates the friction on the front wheel, and hence there is a net motion on the bicycle to move towards the right. If you were to talk about these horizontal forces, one would typically draw they would draw these forces with respect to the center of mass of the bicycle. The center of mass of the bicycle is at the center of the rod, the horizontal rod on the top of the bicycle, on the upper portion of the bicycle. So I talked about what sets the bicycle in motion. I talked about the various forces that are involved. I talked about how the rotational effect is created on the back wheel, how the back wheel rotates. I talked about how the front wheel rotates. I talked about what causes the entire cycle into a linear motion. There is rotational motion as well as linear motion in the process of the movement of a bicycle. Now let me tell you what happens when one applies brakes on the bicycle. Let me think that one had applied brakes on the back wheel of the bicycle. So the back wheel of the bicycle one would apply, and once that happens, the rotational motion of the back wheel, what happens to the rotational motion of the back wheel is that there would be a deceleration. There will be angular deceleration, because it is only the rotational effect that is getting affected. So there will be an angular deceleration of the back wheel. But at the same time, the point of contact of the tire of the back wheel with respect to the floor would have a tendency to move towards the right. Because the back wheel was moving in the clockwise direction, the point of contact of the tire with respect to the floor had a tendency to move towards the left. Now, because the back wheel has decelerated, the point of contact of the tire with respect to the floor has a tendency to move towards the right. And whenever there is a tendency for relative motion between two objects which are in contact, in this case the wheel and the floor, there is a production of a force which opposes that relative motion, and that force here is friction. and that friction will act opposing the point of contact to the wheel with respect to the floor, and it will act horizontally towards the left. Formerly, when the brakes were not applied, it acted horizontally towards the right. Now when the brakes are applied, it is acting horizontally towards the left. Now this has a profound consequence on the front wheel. In the former case, before the brakes were applied, the friction on the back wheel was acting horizontally towards the right, and that friction had an effect of creating a tendency for the front wheel, the point of contact to the front wheel with the floor, to move towards the right. Now what happens to the point of contact to the front wheel to the floor when the friction is flipped over and it's in the opposite direction? It is acting horizontally towards the right. That point will also have a tendency to move towards the right, and to oppose the tendency to move towards the right, the friction will act on the front wheel to move act on the front wheel in a direction which is horizontal and towards the left. Before, the friction on the front wheel had acted horizontally towards the right, and now the friction has flipped over, and it is acting horizontally towards the left. And this has a profound it has a consequence on the front wheel, because the driving torque of um, the friction on the front wheel had caused the front wheel to move in the first place when the friction was acting towards the left horizontally, and it had caused the front wheel to move in the clockwise direction. Now when the friction had flipped over, it is acting horizontally towards the left. Now it will create a torque in the anti-clockwise direction, and therefore there comes a point where there is an opposition to the clockwise torque, and hence the bicycle will either come to a halt or decelerate. Once again, I would like you to observe what is happening in the linear direction. There is this frictional force on the back wheel which has flipped over, and now it is in the horizontal direction towards the left. There is this frictional force on the front wheel which is also flipped over after the brakes were applied, and now it is acting horizontally towards the right. It is the friction on the back wheel that dominates the friction on the front wheel, and therefore the bicycle comes to a halt or it decelerates in the linear direction. So this is how the bicycle, once a person puts a force on the pedal of the bicycle, this is how the bicycle gets into a motion. The most important force that sets the bicycle into motion is the friction on the back wheel, and I told you how through this video. And when the brakes are applied, how the front wheel, even if the brakes are applied on the back wheel, how the front wheel decelerates or comes to a halt. Even this I talked about in this video so far. So I have found this flipping over of the forces in the linear direction really interesting, and therefore I was interested to make this video. Thank you.